So, my dear young friends, we are here to discuss an important topic which forms the basis of many questions, which does come up and appears into the many entrance exams, where we have to find out how many roots a given function fx has, and that theorem is popularly known as intermediate value theorem. So, intermediate value theorem states, let fx be a function in a comma b set, and if fa and fb are having opposite signs, then it can be ascertained and said conclusively that there exists one root between a comma b, that is a pictorial representation to make things clear for you people. If this is x-axis and we have a here and b here, and there is a continuous function fx, okay, one prerequisite for this IMP to hold good is fx should ideally be continuous. So f of a, let's say, has positive value and f of b has, let's say, negative value, then and fx has to be continuous, then the only way the fx can reach here is to cross this axis, and this is the root of the equation. So that forms the basis for this topic. And if f of a is greater than 0 and f of b is also greater than 0, that means a and b, f of a is positive and f of b is positive, either f of a is negative and f of b is negative here and here. So fx does not crosses this line or x-axis, hence no root exists. So, forming basis of this IMP, we are going to delve into another example to demonstrate and make things much more clear to you. Provided, this is a question, provided a is greater than b and is greater than c, prove that the equation x minus a, x minus b plus x of minus x of minus b, x minus c plus x of minus c and x of minus a equal to 0 has two distinct roots. So how will you approach this problem? The problem is simple. Let's say this equation is fx. Now we have to find out that a is greater than, just since it is given a is greater than b and b is greater than c, so the order on the number line, order on the x-axis of A, B, C will be A, B and C. So A is greater than B and B is greater than C. So how will you approach this problem? So first find out f of A. So while you substitute x for A, so A minus A is equal to 0, A minus A x minus B plus A minus B, A minus C and plus A minus C and A minus A. So essentially this will result to 0 and also this will be 0. So here A minus B and A minus C, we are left with this part only. Since A is greater than B, so this has to be positive, and since A is greater than C, so this is also positive. Hence f of A is a positive number, which we can definitely say. Similarly, we'll put f of B to arrive what value we will get. Those then in that sense B minus B equal to 0, so this will be left, we will be having nil value for this part. B minus B will be 0 again here, so we will be left with no value here. So finally B minus C and B minus A equal to, now since B is greater than C, so this will be positive number, and since B is less than A, so this will be a negative number. So essentially FB will be negative. So FA will lie somewhere here. Since FB is negative, FB will write here. Again we will substitute FC. So C minus A and C minus B, C minus A and C minus B, C minus B, C minus C, so this term will be automatically cancelled off because of it being 0, and C minus C again being 0. So we will be left with this equation, this part of the equation x, C minus A and C minus B, which will obviously C being less than A, so this is a negative number, and C being less than B, this is also negative. Product of two negative numbers will be positive. So f of C will again lie somewhere here. So only way the fx function fx can travel is somehow here. So here and here the fx intersects x-axis at two places, and hence we can say that we have two distinct roots of this equation. So it is very clear that IMP is a very handy tool when it comes to solving this kind of problem, and it gives a quick solution to these complex equations. So again, if we have an equation fx equal to x raised to power 4 minus 4x minus 1 equal to 0, so we have to determine that whether a root exists between 1 and 2. So essentially again we will be dealing with 1 and 2. So you are having a situation where x-axis we deal with 1 here, and we have to determine whether there exists a root between these two numbers. So essentially we again will find out f of 1 is equal to 1 raised to power 4 minus 4x into 1 minus 1. So this and this will cancel it out, so this will be 4, a negative value, and f of 2 raised to power 4 minus 4 into 2 minus 1 equal to 0. So that will be 2 to raised to power 4 is 16 minus 8 minus 1. Essentially this is a positive value. So f of 2 being positive and f of 1 being negative, fx does cross the x-axis, hence it is certain a root exists between 1 and 2. So we'll be dealing with one more example before we sign off. Given alpha is the root of equation ax square plus bx plus c equal to 0, and beta is a root of equation minus ax square plus bx plus c equal to 0. Hence we have to prove, here we have to prove that equation a by 2x square plus bx plus c equal to 0 has at least one real root lying between alpha and beta. So this is again an extension of this IMP and variation. This is a variation problem, so nothing to be afraid of. We can deal with this kind of equation. So our fx is this, fx is equal to a to the a by half bx plus c. So f of alpha is equal to a by 2 alpha square plus b alpha plus c, and similarly f of beta is equal to a by 2 beta square plus b beta plus c. So we can substitute here. How do we arrive solve this a alpha square plus b alpha plus c? So a by 2 alpha square plus b beta alpha plus c minus a alpha square by 2. Since we have a relation a alpha square plus b alpha plus c equal to 0. Where do we get it from? This one. So while we substitute a alpha square plus b alpha plus c, so while substituting it, you can derive this equation. So finally, f alpha is equal to minus a by 2 alpha square. In the same fashion, f of beta will be reduced to 3 by 2 of a of beta square. Again, since this is a negative value and this is a positive value, we can conclusively say that there exists a real root between alpha and beta. So that is all for today, covering this intermediate value problems. In case of any doubt, please do comment and you can approach wherever possible. As soon as I have time, I will cover next topic, which is logarithms. Thank you very much.